Let us begin the class. 8 a.m., right?
Yes.
How are you?
Not good.
Not so good.
Not so sure. I thought we can use MATLAB for something, but turns
No,
out
no,
we cannot.
no, cannot. For other purpose can like checking your answer, working on your capstone. The engineering analysis, you really want to test your mathematical skills.
Oh no.
Okay, let us begin the class of review chapter 6. You will have your exam on Thursday, 2 days from now. So we have to review them. Actually, this class for chapter 6 only revolves around this formula. So all of the properties that you have, be it the linearity property, the convolution integral, the shift theorem, S and T shift theorem, all of them are derived from this single relationship. Yeah. So you remember when we want to derive the Laplace transform of step function? You still remember how to do it? The step function u of t is equal to 1. Yeah. So your Laplace transform is what? Integral 0 infinity of 1. Yeah. So we integrate this, we have minus 1 over s, and then e minus st 0 to infinity, which is what? 0 minus 1 in here. So the final result is 1 over s, right? And then when you have the relationship between the Laplace transform of e minus at, what is this Laplace transform? Do you remember? It's the 1 over s plus a. Yeah. So you found this on your table, right? But actually this relationship is derived from what? S shift theorem. Yeah. Integral from the S shift theorem. I give you the Laplace table, right? The Laplace transform pair. All of them are derived from here. And that is exactly what the course intend to do. So the course really want to ask you to derive all of those relationship based on this, and then using the theorem that is being explained in the class. So those are the fundamental theorem in deriving all of the Laplace transform pair. Okay. Let us see review of S shift theorem. Yeah, let us review it. So the theorem says like this. Yeah, this is the line of the theorem. If you want to find out the Laplace transform of a function ft but multiplied by exponential at, then the Laplace transform is just fs, but the s replaced by s minus a. So if it is positive in here a, the shift here is minus a. So that's what the theorem says. Okay. When we apply it to step function 1 over s, so this is our fs. So ft is ut, right? Because fs is 1 over s. If we multiply it with e minus at, then the Laplace transform is just the us with s replaced by s plus a. So as simple as that. Yeah. So you find out that this is 1 over s plus a. And this is exactly the Laplace transform pair. So do you know what is the Laplace transform of sine omega t. This is
1 omega over omega squared.
omega over s square plus.
Omega squared.
I think this is square also. No.
Oh,
So if you have the Laplace transform of e minus at here, I put minus, okay, of sine omega t. Then what happened here?
omega over s plus a squared.
Yeah, this is just s plus a squared. So that's how we use the theorem. Okay. Any question on this? What do you mean? No, but you replace s by s plus a. Yeah, we just replace the s. The t shift theorem is a bit different, not like this one. Yeah, we just did this one. If this is plus here, so if it is plus instead of minus, then you have to what? You put what? Minus sign. Okay. So if we have Laplace transform of t 5t, that is sine tan of t, and the result is just tan s minus 5 plus 100. Okay. Any question? Okay, let's move on. So over here is the solution. Yeah, this is the solution, and over here is the problem. And I show you here the S-shift theorem. Let's check the problem first. The problem is over here. We want to find out the Laplace transform of this one. Yeah, e minus t of sine omega t plus phi. But then the problem already give you the Laplace transform of sine omega t plus phi, which is this one. Okay. So what you need to do here, if you multiply the function by e to the power of minus t, what you need to do here is to replace. Yeah, you replace s with s plus 1. Okay. This is s plus 1, this is s plus 1 squared. Yeah. So as a result, you obtain this. Okay. So the numerator here, gs plus 1, is all of this thing. Yeah. Any questions so far? Yeah? No? Can go on? Oh, yeah. Alright, now we discuss on the T-shift theorem. Yeah, this is a bit different. So you want to shift the time domain function. Yeah, shift the time domain function by a factor of a. And the result is that your Laplace transform, it has to be multiplied by an exponential function. Okay, an exponential function here. So the focus here, when you are having a shift in the time domain function, the focus is that you first find out what is the Laplace transform of the ft. Yeah, Laplace transform of ft will be f of s, right? And then after that, you just multiply with the e minus as. And we can do it the other way around, actually. The other way around, what do I mean by that? Is that if you have a Laplace transform, Laplace domain, but you multiply, there is a multiplication with the exponential function, then its inverse is just the ft. You multiply with the delayed step, but then the t also replaced by t minus a. Okay, an example is this one. Let us find the inverse of this. So how do we do this? Yeah, you have fs 1 over s plus 8. So the first focus to find out the inverse of this. Okay, what is the inverse of e minus 8 of t? Okay, do we have 1 over? No. Oh yeah, just 1s plus a. And then the Laplace inverse of e minus 5s. So we have to shift by 5. Yeah, so we use this, multiply first with, yeah, you can put this in the left or on the right, that's the same thing, but then you also shift this by 5. Okay, yeah, you see it. To make you clear, focus on this one first, get the inverse, after that you shift it. Yeah, any question on this? No, really? You can do it on exam if you find this problem. Yeah. Yeah, I put in the homework a lot, right?
I hope the exam is like this.
Yeah, one of them is like this. No. I mean, they will have. I said to you in the announcement that it will have a time delay input, right? So your input get the time delay, which is this. Sorry, this is a time delayed input. So your Laplace transform will surely have the e as as. Okay, so this is just a review of the t shift. What happened if we shift the time? Yeah, this is the original function, and this is the function shifted by 2 seconds. Yeah, on the middle, this is truncated. Yeah, truncated by the step function, truncated by the delayed step function. So the shape is not a sinusoid, not a sinusoid. Meanwhile, this is 5 over s squared plus 1. Yeah, and this is the same thing, 5 over s squared plus 1, but you multiply with exponential of minus 2s. We use the S-shift theorem. And what about this one? Still remember? I show it to you.
Integral of
Yeah, you integrate it from 0 to 2.
plus integral of plus 0.
So I write it here, Laplace of 5 sine t, 5 sine t, multiplied by u t minus 2. You integrate from 0 to 2, which is 0, yeah? 0 times 5 sine t. And then plus from 2 to infinity of 5 sine t dt. And this Laplace transform only apply for s greater than 2, yeah, because there's a shift. So I show you here the result. This is the result. Sorry, I have to use the exponential here, yeah.
Well, I don't think the drawn because has sign.
Which one?
Zero.
This one? It
No.
has what?
No sign.
Yeah, no, because
Zero.
it's 0. Yeah, 0 multiplied by 570 is 0. All right. And so all of those properties that you have is actually these properties. Yeah. This is a more complete property. The first one is what property is this?
Linearity.
Yeah, both of them are linearity actually. This one linearity, yeah. The 3 and 4 and 5, these are the plus of what? Derivative, yeah. Laplace of derivative is 3, 4, 5. Number 6, 7, 8, yeah. Laplace of integral. And then this one, number 9.
Think this.
So this is just like you want to find out what is the final value of this FD. Yeah, this one, the shift in what shift? S shift. Okay, number 11, the T shift. Number 12, 13, multiplication by T. 12, 13, 14, multiplication by T. Yeah, number 15 is the division by T. Yeah, this is division by T. Yeah, this one I'm not sure, but looks like we use the linearity property in here, I believe. But we haven't discussed about this. Number 17.
Convolution.
It's the convolution. Number 18. Yeah.
Convolution juga kan? Not like the confusion.
Yeah. One place.
Okay, let us discuss the convolution, which it seems a bit obscure. Okay, the answer is over here, but let us focus on the problem first. Okay, get the problem. This problem is not involving a Laplace transform, only the integral. Yeah, so your integral is coming here. Okay, this is the definition of the convolution integral. The first one, you replace t by tau. The second one, you replace t by t minus tau. Okay, and so because the integral is in tau, the t term, you take it out. We can take out the t term. So we have the 2k tau. You integrate this, the 2k becomes here. The 2k here. And then, 2k is here. 1 over 2k. And then you have e of 2k tau. You replace tau by 0 and a t. You get this one. Yeah, and so your final result is 1 over k sine hyperbolic kt. what is hyperbolic is this one. Yeah. Can you get it from here to here? Is this clear? From here to the sine hyperbolic? Michelle,
Itu
is it clear?
Fs sama GS-nya kalau kebalik nggak apa-apa.
No, it's okay.
Maybe I will get it in English. From there to sin hyperbolic.
Say it again.
I don't get the. Isn't it just a property of H?
Yeah. This is just a property of sine hyperbolic. You see, the first one, E minus kt, you multiply with this, minus k plus 2, you become just k, right? EKT, okay? So EKT is this first one?
Yeah. Minus e to the minus.
Yeah, it is minus over there,
Okay.
over 2k. Yeah, over 2k in here. So we take the 1 over k out. and so this a becomes 1 over k. Yeah. Any question? I want to ask you this one. If we take a convolution integral of a function with a delayed step, let's say I have ft is 5t, and then I have a step function like this one, and then I take the convolution, what I will get is integral 0 to t
So
T minus T minus.
So the result is
Is 5t squared.
is equal to this one, just because
T times
this is 1, right? So we can take it out. So the result is just this. Yeah, you get it?
what is ut minus 5?
T minus
Yeah, that's what I want to ask.
Oh.
T minus 5 is 1.
So let's say your GT is ut minus not 5, like we have 5 already there. Why choose 5? 3 lah. Like this one, okay? What about ft? How do you write it?
The integral becomes 3 and 3.
Yeah. So you have 0 to 3.
Or 0 to 3.
Yeah, this one, right? This is delayed by 3 seconds, yeah? You have 0 times f tau,
0.
which is 0.
Yes.
And then plus from 3 to t. I'm using this. And then I have the u tau minus 3. T tau. So what's the result? I will have from 3 to t, but then this is 5t minus tau, or just ft minus tau lah, so you don't confuse. So this part is gone, yeah, because this is 0. Okay, right? So I have this, but I multiply with Why do I have to multiply with this? Anyone know? This is 1, right? This is 1.
Then why is it 1?
Why do I still have to multiply with ut minus 3?
So that from 0 under 3 is so
Yes. Yeah, this is to truncate the function. If you integrate this from 3 to t, even if you put a t equal to 0, t equal to 1, you will still get number. Okay? But we multiply with this so that from 0 to t is flat, no function. Okay? So this thing appear.
Why is u
Huh?
tau minus 3 equals to 1?
Say it again.
Why is the ut minus 3 equal to 1?
This one? Equal to 1? Yeah.
yeah, I'm kinda I think
Uh, So u3 minus 3 is just like this. It's just this one, right?
I don't know.
Okay.
Oh yeah.
Okay, let's move on to the next problem. Okay, what about this? This one appeared in the quiz last time, yeah? Yeah, the answer is here, and that's the problem. Okay, let's take a look. Yeah, let's take a look. Ut minus 1 is a delayed step, and the t is the ft that we have here. Yeah. Okay. And then when we integrate, we have from 0 to t. This is the complete form. Yeah. This is from 0 to t. But then, because from 0 to 1 is 0, as we see here, you only see the term from 1 to t. Yeah. And so when you take the result, you get this. Yeah. But then you remember this integral only appear from 1 to t. 0 to 1 is 0. Yeah. Which is why the format here you multiply with ut minus 1. Okay. So you will get just replace tau with t, and then after that you replace tau with 1. Any question? Looks okay or looks not okay? Alfred, missing for several weeks. Are you okay with this? Huh? Yeah. If you think that this is not okay, just tell us. Which one? From the start. Okay, we have a convolution integral of a delayed step and a function t. So we write it down as this. Yeah. Let me write it here. That the u t minus 1, yeah, you integrate like this, tau minus 1, and then tau t, sorry, tau minus 1, and then t minus tau. Okay, so we know that this function, because it is delayed, we can split the integral limit of the integral. We can split it from 0 to 1, which is 0, times t minus tau. And then from 1 to t, which is 1, yeah. From 1 to t, this step function is 1. So you know what is the delayed step? This is 0, this is 1, this is ut minus 1. Yeah. So only from 1 onwards, it has a value of 1. So you get here 1 multiplied by t minus tau, t tau. Okay. That's we have on the right. And then you integrate this. This one is 0. You integrate this, and the result is that one. Okay. Why it become t tau n minus tau square over 2? Yeah. I mean, do you know why it becomes like that? Maybe some of you do not know. Yeah, with respect to tau, yeah. So let me write it here. This one 0. Okay, let me note it. This is 0. It's gone. And so I have 0 plus from 1 to t d tau, and then I have minus 1 to t tau d tau, correct? Yeah, because of the integral, I split again the integral here t, and this is minus tau, and the result is that from 1 to t become t tau lah, right? And this is a constant, and then this one
Tau square over 2.
half, yeah, tau square, and this is from 1 to t. So that's we have over here. Okay, substitution, you get half t square minus t plus half. Still have any problem on this, Michael? Huh? This one? We integrate the t, right? Yeah, so let me write down what is the integral of t. The integral from 1 to t of t d tau is equal to, t is a constant, right? Constant, so you take it out. Integral of 1 d tau from 1 to t. Integral of 1. Integral of 1. 1 you integrate 1 in d tau. It become tau, which is this one. And the t here is a constant. T and tau is different. Kucing tahu semua. I don't know what I said. I'm just saying something. How about it? Is it clear now? Okay. Can? Clear? Let's move on, yeah. This one. So there is no solution here. So I want you to work on it.
Okay.
One time.
Okay, can you work it on your paper? And then when you finish, you can go to the whiteboard. I'll give you bonus point.
Oke, bagi-bagi lu juga dia.
Ya udah sih.
I will help you by removing this
Okay.
so that you can write
Kerja
right
bagus.
away. Yeah, I will just remove this part. If you need more, you erase on your own.
Depannya mau
If you can work not using convolution integral, I will give you half point. If you can work using convolution, I will give you 1 point. So we can have two methods.
Oh.
Yeah, we don't have to use convolution integral actually. If you only want to find out the solution.
harus tahu.
I give you 5 minutes, yeah, to work on it. Anyone can work on the first method?
Without or with?
Yeah, up to you lah. With and without. So one student will work on convolution and the other one will work on,
Terjadi itu atau
yeah, on the whiteboard. If you have done on your paper, ya. Anyone? Alfred, you want to try? Yeah, you need bonus point, right, Alfred? Come on, the first method, Alfred, you go here. We will guide you. We will guide you. You just come here. We will guide you.
Mereka dulu lah.
So Alfred, you use the method. Which method you want to use? Okay, convolution. use the blue marker, blue one, then you erase the remaining. Just erase all of them. Okay. So when you want to do the convolution, you have to find out the ft and then the gt. Yeah.
Isn't ft just 1? Yeah. Or t?
That's correct.
Initially, I understood was kan kalau misalnya Laplace of f to the FSGS and FS times,
That's correct. Okay.
in which in this case therefore it's f is 1, f tau is this is where I was thinking that
No, f tau is also still 1. You only replace the variable t with tau. It is still 1. Okay.
tau is
E to the power of tau lah.
e minus tau.
Okay, it becomes e.
Or
Yeah. You make a bracket here lah. Get a bracket. Yeah. Okay, that's correct. So now you integrate them. Not this one, but you say Laplace inverse of this. Okay, that is equal to from 0 to t. So it's just what 1 multiply. Yes, and then d tau. The d tau, where's the d tau? Yeah, you only have to integrate this. And now you integrate.
wait, wait.
Which one is the constant in there?
1 out, right?
Huh? No, the constant. One is definitely a constant. There is another constant.
What?
Huh? No, not that one. Can anyone see? In this equation,
How is this?
there is a constant. This one. There we have a constant.
Yeah.
U into the T.
Nah, e to the t is a constant.
Ini kan pakai integral with respect to
Now, with respect to tau, 0 to t is just the limit of the integral.
I see my mistake.
Wait.
limit respect to okay.
Okay.
So
What's your calculus grade?
dulu sir.
Why you are like this? So integrate from 0 to t e to the power of minus tau d tau.
Ya kan.
Okay, now you just integrate e minus tau.
Satu kan bisa
Was it not minus tau?
Now you write et first, e power t first, and then in bracket,
The curly like the
the box bracket. What is the integral of e minus t?
into the power of t is t plus c, right? Yeah. And then like minus plus sign. You have to put the minus.
Minus of e minus tau again. Yeah, that's from 0 to t.
From zero.
Yeah, what's the final result then?
So I put t here, right?
Yeah.
So e t multiplied with minus t power of negative times power of negative 0.
Yep. So the result is
This one is 1. So negative of 1.
this one? No. You multiply with minus.
Wait.
Alfred.
1 minus 1
You see, you have e power of t multiply with minus e minus t. Okay,
Powernya ini.
so you put minus out first. This one take it out. You get not confused. Et times e minus t. Okay, so it becomes minus of e t minus t, which is not 1 in here, minus 1.
Minus 1 plus
Yeah,
E minus 1.
so it's et minus 1. Okay, so the answer is
Iya, minus 1 ya. Minus 1.
C. There
A lah.
Ya lah.
Okay, so that A is the answer. Okay, we want to have the second method. Anyone want to try?
Apa mau? Silakan.
Yeah, over there. Thank you. What's the second method?
What namanya? Using the A.
Yeah,
Oh,
you want to use second method?
Beda kan? Convolution.
Yeah, you go with second method.
Coba ya.
Easy lah, not so difficult. Nah.
aku pakai second method itu agak bingung. Pernya itu cara tandainnya gimana? Kayak ada tiba-tiba harus pakai B, CS gitu.
Yeah, if you want to use the second method, you have to use partial fraction, just to ensure the numerator is correct. Here, Raffi.
Enggak ya? Karena
Itu formulanya itu cara tentunya gimana? Aku lihat kayak beberapa tuh aku bisa bikin kayak bypass cara fit, tapi beberapa salah gitu. Ada CS gitu.
Why you put the minus over there? Oh, okay. Yeah, so he's using Laplace table. Yeah.
Ya nggak salah sih.
Yeah, it's not wrong. You use the Laplace table. What about to use the partial fraction? If you use partial fraction, what do you do?
Coba kan. Di itu aja nggak sih A per S ditambah seper B per S satu terus dikalikan. Coba tunjukin aja Vi.
You remove that one, Raffi. You remove the
Nggak ada yang mau.
right
Coba
part.
deh. Boleh coba.
All of them on the right. No, this is okay lah.
Yang kanan.
My part, you remove my part. Yeah,
Coba kan.
so that you know how to use the partial fraction. Okay.
Coba tes deh.
Is equal to A over S plus B over S minus 1. Left and right you multiply. Yes, that's correct. Wait. Complete the bracket. Yeah. Ya. Minus 1.
Plus aja sih itu. Jadi B itu minus I. B sama minus I.
No lah, B is 1 lah.
Ya minus I 1.
So
And minus 1 dan 1.
and that's it. Okay, yeah, that's how we do it. Unless in the exam you have to give a clear step. Yeah, I mean in the exam, what is this one? So this one is coming from where?
The partial fraction.
Yeah, you in the exam you have to write down that the Laplace inverse of 1 over S is equal to Laplace inverse of minus 1 over s plus Laplace inverse of 1 over s minus 1. And you get this become minus 1, and then this one becomes E40.
Kalau kita pakai cara ini, I-nya tuh masukin apa?
Hah?
Satu.
Which part? If you use this, no, you don't have to input anything. This is not an integral equation. There is no limit in this case. But when you use convolution integral, there is a limit from 0 to t. Over there is no limit. No need to substitute the t with anything.
Oh, okay.
Okay. Say that again. This one? This? No. The original equation. This is a sentence, yeah. You cannot just say, I want to eat. I want to go there. Come with me. No, you have to say the story. What's the story, right? The story is that we want to find out the Laplace inverse of that function. And after going through the partial fraction, we obtain that this is equal to that. And so finally we obtain this. And that's the story. Let us move on. We still have time. Wow, this one.
Mana?
That's a lot of things to read.
Aduh, ini kayak project. Ini kan.
This one is coming in, I think, exam in 2 or 3 years ago. But it is a good practice because it has a Laplace transform with convolution integral, and also we have the ODE solving problem. Okay. Yeah, while you read the problem, try to understand. I will erase this.
Just
MATLAB with I use MATLAB pencil.
Okay, let me tell you something, yeah. In the exam, you will be given a problem of solving differential equation. So there is no problem like this one. Like this, it won't be there. But this problem will be embedded in the problem. Yeah. Like for example, this one, yeah. Evaluate the convolution in part C. Also, this is an embedded convolution integral problem. Okay. Yeah. What I want to tell you here is that if you can solve the problem, but without following this, there are several steps in here. I have 5 steps. If you can answer the problem without following the step, I will give you 80%. You get what I mean? Yeah, like what Alfred did. What Alfred did is to follow what the problem wants him to do. So he get 100%. By the way, Rafi, you do the partial fraction, which is not asked by the problem, but solving the problem, right? You get 80%. So in the exam, I will apply that. There will be instruction like that. 3 questions. All of them are like this.
Berapa itu satu jam?
I believe it at least 1.5 hours.
Ketiganya.
Yeah. Yeah, you read about the L'Hopital rule. You read on that. You are taking a limit where your denominator is 0. Yeah, you want to define something by 0. What you have to do, you just have to take derivative of the function. Take derivative of the function. Okay. Yeah. Cheat sheet.
Laplace table.
You only have the Laplace table with you, right? So the cheat sheet on the S-shift theorem will not be given.
Shift theorem? You mean by that?
S-shift theorem, T-shift theorem, convolution integral formula. It will not be given, but you can bring the Laplace table.
Laplace table.
Yeah, Laplace table only.
Provided or
You bring it on your own.
Pakai ini sir, pakai laptop nggak
Now
apa-apa.
the discussion changes to the exams rules, not
Yeah.
this one.
I mean we need to prepare sir.
Yeah.
the example with
This one is given. Or this one you will be given. So there will be no problem of you deriving the differential equation. No,
Oh, not like the homework.
not like the homework. Homework number 43 ya. No, it will not be given.
Aman ya harusnya. Shift theorem.
Which is why I discussed also that homework last week. Yeah, the deriving the equation. Did you follow that? Yeah, because you are not taught on that. Okay, anything else related to the exam?
Pakai Laplace table-nya di laptop aja.
No, you print it out. A laptop cannot be open. You cannot open laptop, smartphone, printed.
Semuanya aja nggak apa-apa kan?
Hah?
Nggak ada bagian yang nggak boleh kita print.
You can print the 3 of them. It has 3 pages, right?
Okay.
You can print the 3 of them. Do you know what I said by S-shift theorem will not be given, T-shift theorem will not be given, convolution integral formula will not be given, but you can bring the Laplace table. Do you know what I mean? No.
Yeah, that's all.
What's the Laplace table content? What's the content of this Laplace table? Yeah, all of them are there, right?
Yeah. Yeah.
So what are you so surprised at?
I was just.
It's all there.
I was just.
All of the theorem are there. So you can use that.
I was confused by your argument. I thought we cannot print that function that have just T shift and S shift on the laptop.
You can bring the Laplace table, but I will not give you the S-shift. I will not give you the S-shift theorem.
Hey.
Okay. This one. What about this? What to do?
Read the problem first.
The problem says 0 initial condition, okay, and then A is less than B. So if in that case your input indicator function is going to look like this one. Yeah, just like this. This is 1. Okay. Yeah, and by the way, I derived this already. Why it has ut minus b, I know it now. The first step you have to take is take Laplace transform of ODE. What are those?
S quadrat itu S quadrat XS.
So you have x
square
dot
plus 5x dot plus 6x.
Okay. Take Laplace transform for ODE.
S quadrat XS. S quadrat XS.
And this is because the problem tells you this, it has Laplace of this one. Yeah, I advise you do not convert this into Laplace transform yet. So you just write down like this. Yeah, sometimes it is easier if we keep it like this first. Okay.
So at the end.
So what is the Laplace inverse of the Laplace transform of t?
Laplace.
Yeah, it's just t, right?
Yeah.
So later on, if you can find out some equation so that you can put the Laplace inverse in there, you can pop it out again. You don't have to convert it back and forth.
Oh, okay.
That's what it meant. Yeah.
But at the end, we don't need to do that. We just need to Laplace.
Yeah. Okay, so this one answer the first. Is it number A? So for Lxs equal to L of x. Okay. So you have s square. Sorry.
xs times s squared times x xs.
A Laplace of that, and then your xs is the Laplace of ab t s square plus 5s plus 6. Okay, and so xs is the Laplace of x, yeah. So we already have the format in here, yeah. Okay, this format is already in the form that is being asked by the problem.
Okay.
Oops. Okay, now can you tell me where does the linearity is being used? In which part linearity? Any idea? Now up to this point, where does the linearity be used? From here to here, where does the linearity being used? We only ask this point, right? Where is the linearity of the Laplace transform being used? Where?
S squared plus 5s.
No.
D1t plus D1.
No, not this one first. Answer the explain where you use the linearity. Where? Which part? Which part of the ODE? You don't know? When we convert the Laplace transform of x double dot, which is s square of xs, do we use linearity here?
There's one outside of the Laplace.
With this one, there is no linearity involved, lah. With this one, that's too simple.
Yeah,
But if we have the
x,
5x dot,
five.
so this is equal to 5. So that is 5. So this is where the linearity is being used. Okay, that's what the problem asks you. You get it? Yeah. Because in the theorem that you have, the Laplace transform of derivative, you are only given the theorem for getting the x dot. Okay,
It only on the X dot and not on the 6.
of course as well. Yes.
X dot.
And you say Laplace of 6x is just 6 times Laplace of x. Yeah. Okay. So simple, but that it's what being asked by the problem. So simple, you don't want to answer it, right?
You don't know.
Or you say that there's no point in answering this.
You don't know where it is.
Say it again. 1 point gone. Yes.
Oh, yeah. Go on.
Yeah, the answer is this. Okay, the second one, you factor out the polynomial and express as a 2 function. Yep.
A 1 over S squared plus 1s.
Can you factor out the 1, 5, and 6?
Yes.
It becomes what?
S.
Yeah. So
Ayan.
is S plus 2 and S plus 3.
Baca sir jawaban.
No. You have to find out each of the S plus 2, S plus 3. You have to do the partial fraction
Jadi kasih upper.
so that you find what is the GT, G1, and G2. Have you ever heard a car named Feroza G2? Feroza G2. Never heard of that? Yeah, there is no G1 actually. Came out as the first one G2. G2 means precise G2, yeah. But it's written as G2. I don't know.
Oh.
Yeah, you read G2 as which is precise, okay?
Oh,
And the price is higher than the standard one.
Saya ya.
Just because you have the G2 badge on it. Yes. So let's solve on that. The 1 over S squared plus 5s plus 6 is equal to A plus B. This is S plus 2.
S plus 3.
So
1 equals
this is 1.
A times S plus 3 plus B S plus times S plus 2.
Okay. So you put S minus 3, you get B, yeah? 1 is, okay, S is minus 3, B times minus 1. So B is minus 1. Yeah? Minus 3 plus 2 is minus 1, yeah?
Minus 1.
It's 1, yeah. 1 is equal to minus B.
Oh yeah.
So
Times ya times.
B is minus
My
1.
bad. I
And in here, if you put S equal to minus 2, 1 is equal to A minus 2 plus 3 plus 0. So
1.
A is equal to 1. Yeah. So as a result, we have 1 over plus minus 1. So how do we write those? We write it now as 1 over S squared plus 5s plus 6 is equal to Laplace of what? E minus 2 and then minus okay, like this, yeah. So this is what the problem want you to do.
Oh.
Like the inverse Laplace coin. Is it the C part?
Yeah, I can understand that following the step is a bit, sometimes it's not so unnecessary lah. Sometimes, yeah. You can readily solve it, I believe, yeah, without using all of this stuff. I know. You get B.
Lu,
Yeah, 80% lah you get B.
kalau kena time sih langsung aja pakai yang satu aja. Di
Okay. Now number three. This is number 3.
the inverse of the 4, next to the right.
So what does that mean?
Inverse Laplace.
What does that mean?
Inverse Laplace of x. What is the x constant? That's right. The x a.
This one.
Yeah.
We are still keeping it. This
Does the x have a name?
Chai.
Chai.
You go into your Microsoft Word, get to the equation, you write down. Yeah. You get that. Chi or chai, I don't know.
We take the inverse Laplace of whatever the right hand side in the form of. Also, we make x as become f.
What do we want to do here is that we start from here, yeah.
Yeah.
Start from here, and we write down L of x is equal to L of the indicator multiplied by, we write using that, yeah.
Yeah. Laplace.
And that's the Laplace of minus 2. Okay. And so if we take the inverse, this is two Laplace transform, you multiply together, right? So we know that we take the inverse, and we take the inverse all of this. We know that it becomes xt is the chi AB. You do with e minus 2t and e minus 3t. Okay. Convolution integral between these two. Then you get 2 points. So actually this 2 point is coming from your understanding what is G1, G2, and then how do we get the X from here. Okay. So from part A, this is part A, yeah? Part A, and combine with part B. This is coming from part B. Okay. We take Laplace inverse, we get the xt here. Because this is a product of Laplace transform, it becomes in convolution integral. That's when the convolution integral comes in. Come into play. And then you just have to use the formula to evaluate this. Just evaluate that. Let us use the linearity property of convolution. So it becomes first one, and then the second one. That's it. So you work one by one, get the value, then get the result. Okay, use that. Any question on this? No? Clear?
Now, so there will be ut minus a and minus ut minus b. Yeah. Being integral.
Yeah.
Being integrated.
No. You only integrate e minus 2t here, e minus 2t here. This one, you don't do anything. No, you don't do anything.
Yeah.
Yeah,
What?
you don't do anything.
Integrannya dirubahin.
Now, we use this formula. Let me show you for the first e minus 2t. Yeah. Then you work on e minus 3t on your own.
Okay.
So your chi AB e minus 2t. Say that again.
Oh ya.
A to B, right? So this is A to T, sorry. And then this is E minus 2 T minus tau, D tau. And then you have to multiply with this. Yeah, I'm following this.
Yeah.
Yeah, just follow the formula.
Is that given to us?
It's given.
Oh, it's given.
I just crop it to the right so that I can enlarge the page. This formula will be given.
Oh, I thought that was like part of the ways to solve.
And then plus integral from A to B. Yeah, A to B and E minus 2 T minus tau. And this is U T minus B. Okay. So what's the result of this integral?
Integral.
Minus half, okay. Minus half E minus 2 T minus tau. Okay. What about this one? At the same line, actually. This is from A to B.
Why the integral A?
Sorry?
Why we integrate A to T?
A to T. Yeah, that's the result of decomposing this. I have proved it, but I don't have time to work in it. After the class, I can show it to you.
So we just follow.
Yeah, you just follow the formula lah.
So if we already do it correctly, we just need to follow the formula.
Yeah. And then you T minus B. Sorry. T minus tau, yeah?
Yeah.
So we replace it from A to T. We put T here become 1, yeah? If we put T here, it become 1.
Yeah,
Okay.
1. T become 1.
So it's become minus half and then plus half T minus 2 T minus A of chi AB. Okay.
Plus
And then this one,
minus
okay, we put minus half out.
E.
We have E minus 2 T minus B and then minus E. This is U T minus B. Okay.
Yang itu kita berapa?
Any issue on this? Is this clear? Yeah. If you derive one more term on that, you will have this term multiplied by indicator function and another set of exponential multiplied by the ut minus b. Okay. the final result will be this. Yeah, the response will be given by this one. Why is that so?
But we haven't updated the
Which one?
yeah.
Yeah, on the minus 3t, you will have the minus 1/3. This is e minus this is t minus b, t minus a here, okay, and u t minus b. So you will have another term like this. Yeah. What I want to say is that this term exists only for the time a to b. Yeah, from a to b only. This term from a to b only. Beyond b, this is 0. Okay, this term beyond b, this is 0. So the response of the system that will persist is this one, because this is after b, you will still have a value on this one.
Okay.
Okay, and then let us ask the last part. Okay, so I have answered on part D. Then I left the work on the second term to you.
Yeah.
What about the last part?
So
He approaching
Does the solution go to 0?
wait. Kalau t-nya tambah besar, pangkat besar itu 0 ya?
Yeah, if t goes to infinity, what will happen with the solution?
goes
Minus half.
This is multiplied, yeah, multiplied.
Okay.
You cannot see it? Approaching 0, that's correct.
infinity kurang
Approach 0, not infinity. This is approaching 0.
Kalau pangkat 0 itu infinity 0 dia.
pangkatnya zero.
Iya.
Minus infinity, ya.
Minus
Oh,
Not plus infinity, but minus infinity. So this one approaching 0, this one approaching 0, yeah.
Yes.
This one also approaching 0.
Oh, we just see the yeah, right. We just see the
Yeah.
one that giving input, right?
You only need to evaluate this one, yeah, whether of this. Does it go to 0 as t goes to infinity? And yeah, of course, a is positive. Yes, it goes to 0, yeah. And then the next question, if it approaches 0, does it oscillates? Does it oscillates? Do you see any oscillation here? If it is oscillates, what is the term you have to see here? Sine cos. Okay, so it doesn't oscillate. So the answer is that. Does it oscillate? No. Okay. It doesn't oscillate. And then this one is wrong actually. This is not critically damped, but overly damped. If it is critically damped, you will see a double value here, -2 and -2. That's critically damped. If the number is different, -2, -3, then it is overdamped. If it's underdamped, it has sine and cosine term. Yeah, sine cosine term, it is underdamped. Now it doesn't ask you whether it is underdamped or overdamped. It doesn't ask you that. It only asks you, does it oscillate or not? You say no. That's the final answer. It doesn't oscillate. That's it. And then the problem tries to tell you, oh, this is not oscillating and this is critically damped oscillator. It is wrong. This is not critically damped, but overdamped. Yeah, you know, the style of the problem is really want you to treat this problem beautifully, you know. It's a very, how do I say this, a delicate way to solve the problem. Yeah, you see, the way Dr. Wayne Hacker wrote the solution is like he's still saying it's the Laplace of this. Okay, this is the Laplace of this. Very treating it very delicate, in a delicate way.
Very mathematician like.
Yeah, so yeah, I respect that method because he is respecting all of this solution as one of his expertise. Yeah, and then the way he tell you about the problem is that he really thinks you as a kid, actually, if I have to say, because he he really guides you. If I were to give you the problem, I will not do this. I will just ask you, solve the problem. Does it oscillate? That's it. I will let you choose the method. I assume that you are a grown-up person, but Dr. Wayne Hacker is still think of you as a kid. You have to be grateful on that. All of the steps are yeah. Okay. So on the exam, if you see the steps, you follow it, you get 100. If you don't follow but still get the correct answer, I will give you 80%.
I will get like 3 of these.
Yeah.
3, yeah.
So 3 of these.
Another problem, you will not be given the step. I don't know. Do you give? Did he give the step or not? I think all of the problem has the step you have to follow, if I'm not wrong. Yeah. Yeah, including the Hospital rule. The Hospital rule. Yeah. Okay, so our time is up. I'll see you again on Thursday. Remember that you can still reach me at IoT Lab if you want to ask about concept